What I was saying is a reference angle, we're going to call it theta in our examples here, is the distance from the terminal side of an angle to the x-axis. And we said distance is always positive. You're never going to have a negative. So your reference angle will always be positive. It will always fall between 0 and 90 degrees, or if you're in radians, 0 and pi halves. And that's because the furthest away from the x-axis that you can be is the y-axis. And if you're on the y-axis, the x-axis is a 90-degree angle, right? Once you go past the y-axis, for instance, this quadrant 2 angle, you're getting closer to the x-axis again, just on the negative side. So 90 or pi halves is the furthest away you'll ever be from the x-axis when you're drawing an angle in standard position. Okay, so here is a depiction in each quadrant of what a reference angle would look like and how to find its value. So if we have theta, our given angle is in quadrant 1, it's this acute angle, our reference angle is actually going to be equal to it. Okay, they're going to be the same size because how far is this terminal side from this x-axis? Well, it's the exact same size as the angle. But once you go into quadrant 2, you can see we have this obtuse angle theta. The reference angle is now over here because the terminal side is closer to the negative side of the x-axis. Okay, so your reference angle can be found by doing 180 minus theta, the original angle. Or if you were in radians, that would be pi minus theta. If your original angle theta is in quadrant 3, you can see here's the terminal side. Here is now alpha, the reference angle. Okay, so now you've gone past 180, so you have to get back to it. So you take the angle minus 180 or minus pi if you're in radians. And then if your angle is in quadrant 4 here, this would be your reference angle. You're now closer again to the positive side of the x-axis, to 360 degrees. So you would take 360 minus the given angle, or 2 pi minus the given angle if you're in radians. So we're going to try that with example 1. We're going to sketch the angles in standard position and give their reference angle. Okay, so where would 300 degrees be? What quadrant? Quadrant 4, because if I go, this is 90, 180, 270, so 300 would be here-ish. So if this is 300 degrees, and if I went all the way back around, that gets me to 360, right? So I'm looking for this angle. This is the reference angle, the distance from the terminal side to the closest x-axis. So how big would that angle be? 60 degrees. And I'm going to show the work. I know most of you would just do this in your head, but for the sake of your notes, I'm going to write it down. We're doing 360 minus 300. That's where 60 degrees is coming from. So this angle is 60 degrees. Okay. All right, negative. I'm going to jump to C and stick in degree mode for now, and then we'll move on to radian mode and go try those. So negative 240 degrees, where would that be? Nope. Positive 240 degrees is in quadrant 3, but not negative. Say it again. Nope, not 1. 2. Okay, so watch as my terminal side rotates. I'm going in the negative direction. There's negative 90. There's negative 180. So negative 270 would be here. We're going negative 240. So it's about right there. So in the negative direction, 240 degrees. Does that make sense now that you see it? Okay. Now the reference angle is how far is that terminal side from the x-axis? So this right here is what I'm looking for. Well, in the negative direction that we're traveling, we're saying this would be negative 180. So we're asking for the distance from negative 180 to negative 240. What would that come out to be? Okay, I heard negative 60, but what did we say? is always positive, always positive. 2 negative makes a positive if you're multiplying. We're not multiplying these, we're just finding the difference between them. If I were to subtract, if I were to do negative 240 minus negative 180, it does come out to negative 60. That's why I'm reiterating that it's always positive, because it's just the distance between them. Okay? So be careful with those. Now, for the radian measures, I'm going to do what I did in the notes last week and draw the dashed lines to help you break this into the, in this case, the pi thirds angles, and in D's case, the pi fourths. So remember I told you the denominator is how many dashed lines you'll draw through your coordinate grid to create the pi thirds angles. So 3, you start with the x-axis, that would be 1, 2, 3. So you have 3 angles on top, 3 angles on bottom. Remember, when it's the odd number like that, it didn't include the y-axis. But when we do the fourths, it will. And while I've got this tool, I'm going to go ahead and break the fourths up. So I'm going to draw 4 dashed lines, and that does include the y-axis. So there's 1, 2, 3, 4. So 4 angles on top, 4 angles on bottom. Those are each a pi fourth angle. So now for part B, I want to sketch the angle in standard position. I'm going to start, my initial side is the positive x-axis. So I'm going in the negative direction, so clockwise, 2 pi thirds. So I'm going to count those dashed lines. So that would be 1 pi third. Oops, that was not supposed to stay there. Try that again. 1 pi third, 2 pi thirds in the negative direction. So when you've drawn it out using the dashed lines, it's actually really easy now, because you can just count between the 2 dashed, where the terminal side is and the x-axis. How big is that? If each of these angles I created, how big are they? A pi third. It's 1 pi third. And it's always positive, it's not negative. Okay, I'm going to go ahead and, I didn't put the label on here. So this blue terminal side, this is at negative 2 pi thirds. And if you think about your angle here, pi, in terms of thirds, this would be negative 3 pi thirds going in that direction. So the distance from negative 2 pi thirds to negative 3 pi thirds is 1 pi third. Guys, please stop your side conversations. All right, so we've got an initial side here, and we want to rotate in the positive direction 5 pi fourths. So I'm going to go 1, 2, 3, 4, 5. So it's going to put me here in quadrant 3. So this is at 5 pi fourths, which if we think in terms of fourths, instead of pi, we can write that as 4 pi fourths. So the distance between those is what? 1 pi fourth. And you will notice that once you start working with radians more, getting reference angles, see, that one was pi thirds and this one was pi fourths. The radians are actually going to be really easy to work with. You're good with reference angles? Okay. So now we're getting to a point where we're going to bring that trig we started the unit with back in to what we're doing with the unit circle. Okay, so this is at the bottom of one of your pages, and then this is at the top of the next page. It just didn't print on the same page the way that it flowed, but I'm going to look at them together. So both of these little synopses are talking about if you have a tangent line drawn along the unit circle, tangent at 1, 0. So it touches at this point right here. Okay, and you consider that a number line, this point T. Okay, so the distance from here to here is T units, if you're considering this 0 on the number line. Okay, if I were to wrap this line around the circle, okay, that T would end up a point on the circle with coordinates X, Y. They're calling it point P. Okay, you could see if it was further up the number line, it may end up looking like this, but that distance T, that becomes the arc length, which is the angle in standard position. Okay, so whatever that number T is on the number line, that is the angle measure. Okay, does that make sense? Kind of, sort of. Now, if this is on the unit circle, we know that the radius is 1. Okay, but we can look at those points X, Y as the horizontal movement and the vertical movement from the origin. So I'm going to sketch that out a little bigger up here, this triangle that it creates. Okay, so this is the origin, 0, 0. Okay, and this is that point P, which is X, Y. And this horizontal movement is the X value. The vertical movement is the Y value of that ordered pair, because you're coming from 0, 0. And it's the unit circle, so we know the radius is 1. Now, that angle T is out here, outside that triangle that I drew, but this is the reference angle. So I'm going to use the reference angle that's at the origin, that central angle inside the triangle, and I'm going to label O, A, and H from here. So this is opposite, adjacent, and hypotenuse. And let's see if you recall your trig ratios. What was the ratio for sine of theta? And you know what? I'm going to actually use, since we were talking on the last bit about reference angle being alpha, I'm just going to call it alpha. I'm going to label it alpha here. Okay, now if you want to consider the XY axis here, that angle, that's the T angle from here. So the given angle is T, and I'm using the reference angle alpha. Now sine from alpha is going to be the same as sine from T, because that ordered pair isn't changing. And if you look at from here, opposite is Y. Instead of O, I can put Y. And the hypotenuse is 1, since this is the unit circle. What is anything divided by 1? Itself. So sine of this angle, sine at this ordered pair on the unit circle, is the Y value of that ordered pair. So sine of that angle is equal to Y. What about cosine? What's the ratio for cosine? Which is x over 1. And we said anything divided by 1 is itself. So cosine of the angle here is x. And I accidentally used theta again. I said I was going to keep using alpha. Sorry. Okay, but really you could put sine or cosine of alpha here, or sine or cosine of t. Because we're just using it as the reference. From the reference angle, we're labeling OA and H. But the t is really the given angle in standard position. So I'll use that instead. Sorry to change that on you again. But that's how it's listed here, so I'll try and keep it consistent. So you can see in this little key concept box that it says that sine of the angle in standard position is the y value of the point on the unit circle that terminal side intersects. And cosine of that angle, t, is the x value of that ordered pair of the point that it intersects. Now tangents, what's tangents ratio? Opposite over adjacent, and we look at that, that's y over x. So you can see tangent is y over x. And then they list cosecant, secant, and cotangent. It's the reciprocals of those. So instead of y, 1 over y, x, 1 over x, and y over x flips to x over y for the reciprocal of each of those. Okay, so the coordinates of that point P can be written as cosine t, sine t, instead of as x, y. So that's what we're going to put here in your notes. Whatever your angle is, cosine of that angle is the x value of the point on the unit circle that it intersects, and sine of that angle is the y value of the point on the unit circle that terminal side intersects. And just like we said up here, that tangent is going to be y over x. Remember, back in part 1 of our notes, when we were learning those trig ratios, we showed that tangent is sine divided by cosine. And so since sine is y and cosine is x, tangent is y over x. A somewhat common mistake in listing the ordered pairs or coming up with the trig values of that angle is mixing up the sine and cosine. Students tend to want to put sine for the x and cosine for the y. And I think that's just because, like, when we say SOHCAHTOA or on the calculator, when you look at the buttons, the order is sine is first. We say sine, cosine, and tangent. So people want to write sine first here as in the ordered pair. So just to help you remember that cosine comes first, remember that it's alphabetical. Okay, just like x comes before y, c comes before s. Y'all all right with that? Okay. Now let's look at our quadrants. If we're going to start finding trig values on the unit circle, we need to know when and where those trig values are positive or negative. So we're going to consider just ordered pairs in general. If I have a point in the first quadrant, I know the x and y are both positive because from the origin, I went right and up. That's a positive and a positive movement. If I have a point in quadrant 2, I went left and up, so that's negative, positive. Quadrant 3 is left and down, so negative, negative. And quadrant 4 is right and down, so that's a positive, negative movement. So what we said a second ago is that cosine corresponds to the x value. So whether or not cosine of an angle is positive or negative will depend on what quadrant that angle is in, the terminal side. So if it's in quadrant 1, cosine's going to be positive. If it's in quadrant 2, cosine's going to be negative. If it's in quadrant 3, negative, and if it's in quadrant 4, positive. Now we can look at the y value of the points in each quadrant, and we know that that corresponds to sine. So in quadrant 1, sine is also positive. In quadrant 2, sine is still positive. But in 3 and 4, sine is negative. Now for tangent, how do you remember tangent? It's sine divided by cosine. So a positive divided by a positive, that's still positive. A positive divided by a negative is negative. And a negative divided by a negative comes out positive. And then in quadrant 4, a negative divided by a positive is still negative. Now, rather than having to go through that thought process every time, we've got a little memory trick, a mnemonic, to help you remember which trig function is positive. And the mnemonic device is all students take calculus. Okay, and that ASTC represent the trig functions that are positive in that quadrant. So you start in quadrant 1 and you go around quadrant 1, 2, 3, 4, ASTC. Okay, the A actually does stand for all. All of the trig functions are positive in quadrant 1. You can see that here, positive, positive, positive. Okay, in quadrant 2, the S is for sine. And you can see that in this list. Sine was positive, but the other two are negative. In quadrant 3, the T is for tangent. Tangent is positive in 3, but cosine and sine are negative. And then in quadrant 4, the C is for cosine, which you can see is the only positive one in 4. Sine and tangent are both negative. So ASTC, all students take calculus, all sine, tangent, cosine. Okay with that? All right. So now let's put that on our unit circle, that blue unit circle printout I gave you on Friday. Y'all, get off your phones, put them away. You should have your blue unit circle page out. We're going to fill this, this outer part of each quadrant in. Okay, so on what? On all of them, yep. So in quadrant 1, it says positive. This is asking about trig functions. What trig functions are positive in quadrant 1? And it's all of them. You can list out sine, cosine, tangent, or you can list out sine, cosine, tangent, cosecant, secant, cotangent, or you can just write the word all. Okay, none of them are negative in quadrant 1. Okay, now in quadrant 2, remember we said A, S, T, C. All students take calculus. So here, sine is positive, cosine and tangent are negative. Now you can list out the reciprocal ones here. Just remember the reciprocals stick with each other. So if sine is positive, cosecant is positive. Cosine is negative, secant is negative. Since tangent is negative, cotangent is negative. Okay, so if you want to actually list out all 6, you can. I'm just going to list out the sine, cosine, tangent. So in quadrant 3, the T, that's tangent, is positive. Sine and cosine are both negative. And then in quadrant 4, that's the C, cosine is the positive. Sine and tangent are both negative. Okay, so again, that's referring to what trig functions are positive and negative in each of those quadrants. Now, looking at these ordered pairs, we came up with these ordered pairs last week using special right triangles. And what we just said is that if it's a point on at 30 degrees, cosine of 30 degrees is going to be square root of 3 over 2. because the x value of the ordered pair corresponds to cosine at this angle. The y value corresponds to sine. So sine of 30 degrees is 1/2. At 45 degrees, sine and cosine are both square root of 2/2. Are y'all seeing that? Does that make sense? Okay. Now, I've referred to these. We just hadn't had them formally written in the notes, so now we will. Quadrant angles. Those are the angles in standard position where the terminal side is on an axis, on the x or y axis. So that's 0, 90, 180, 270, and then 360 would be as well. Okay, so if the terminal side is on an axis, we refer to that as a quadrant angle. Okay. All right. So like I was saying, last week we determined all of these values for sine at 30, 45, and 60, those three special angles. And we determined what the cosine was. And that was our ordered pair. This was x, and this was y. Well, if tangent is y divided by x, I can figure out these tangent values. Now, they are listed there, but I want you to see where they come from. So let's say tangent at 30 degrees as an example. Okay, so y divided by x. So that would be 1/2 divided by square root of 3/2. What do we do when we have fractions in fractions? What was that? There was a couple different sayings. Like some teachers may have taught you as keep, flip, change. So I did the little limerick for you last week, or maybe the week before. It's like dividing fractions as easy as pi, flip the second and multiply. So you take the second, that's the denominator, you flip it and multiply. So instead of square root of 3/2, it's going to be 2 over square root of 3. So flip and multiply. Now when we do that, we get 2. Well, actually, we don't even have to write those out. What's going to happen to the 2's? Yeah, they're going to cancel each other out. You got a 2 in the denominator and a 2 in the numerator. So it's just going to come out to 1 over root 3. Now there's the next issue. We don't leave radicals in the denominator. So we're going to rationalize. I went over this process. I reviewed it with y'all last week. So in the numerator, 1 times square root of 3 is just square root of 3. And square root of 3 times square root of 3, that drops the square root, and you're left with just the 3. So tangent at 30 degrees, that's where square root of 3/3 comes from, doing sine divided by cosine. Now at 45 degrees, sine and cosine are the same, the x and the y. So anything divided by itself is, come on y'all, 1. Okay, anything. So when the x and the y are the same, the tangent is just 1. Okay, now here, the 60 degrees, remember it flipped the x and the y. So the 1/2 and the square root of 3/2 switch spots. So that's just the reciprocal of what we did already. So if you took this 1 over root 3 and you flipped it, it's just root 3. Okay, so there are the tangent values at those special angles. So we're going to go back and we're going to add those to our unit circle. Okay, so at 30, we said tangent came out to be square root of 3/3. At 45, tangent was 1. And at 60, it was the reciprocal, so it's just square root of 3. Now, okay with those 3 values? What about at 0 degrees? What is y divided by x here for this ordered pair? 0 divided by 1. 0. So where else on the unit circle would tangent come out to 0? Say a little louder. Not at the top, because if I come to the top at 90 degrees, it's not 1 divided by 0 anymore, or 0 divided by 1. It's now 1 divided by 0. Can you divide by 0? No, that is undefined. Yeah, so the one on the left at 180 degrees is 0 divided by -1. That is 0. But go ahead and put undefined at 90. Where else would tangent be undefined? Yeah, 270. Good. Okay, so we'll stop with tangent there for now. We're going to go on to the next thing. So we're starting to get more and more of our unit circle filled in, right? All right, so to fill in the rest, what we have to realize is that every angle in quadrant 1, this is why I was saying I really need you to learn quadrant 1, why it's so important, is because everything from quadrant 1 reflects over to the other quadrants. If I were to fold this circle across the y-axis, okay, so like hot dog style, if you're folding your paper up and down, you know, this point is going to match over to this point, right? And if I were to fold it down like hamburger style, this point would reflect over to this point because they are all a 30-degree reference angle. They're all 30 degrees from the x-axis. If the reference angle matches up, the ordered pairs are going to match up. They're going to be the same xy value. It's the same distance along the x and distance along the y. The thing is, it's not just about distance. The distance is going to be the same, but what quadrant you're in will determine the positive or negative. Remember, this is positive, positive. This is negative, negative, positive, negative, negative, and positive, negative. So at every 30-degree reference angle, so if I'm 30 degrees from the x-axis in quadrant 2, I'm at 150 degrees, right? So at the 150-degree angle, the ordered pair is also square root of 3 over 2, 1/2. But this time the x is negative. So it's negative square root of 3 over 2, positive 1/2. When I'm 30 degrees away from the x-axis in quadrant 3, I'm at 210 degrees, and both x and y should be negative. So this should be negative square root of 3 over 2, negative 1/2. And if I'm 30 degrees away from the x-axis in quadrant 4, I'm at 330. And my ordered pair should be a positive x, a negative y. So positive square root of 3 over 2, negative 1/2. So do you see what I mean when I say it just reflects over to every other quadrant? So all of the angles that have the same reference angle will have the same distance from the origin, the same x distance and y distance. The only thing changing is that positive or negative. So far, so good? So let's fill in the rest of our unit circle then. I'll get my unit circle back up. So I'm going to go ahead and fill in those I just did at 30 degrees. I said this would be, and if you want to on your unit circle, you can write that plus plus for quadrant 1, negative plus, negative negative, positive negative. okay, to help remind you. So this would be negative square root of 3 over 2, 1/2. Here at 210, it would be negative square root of 3 over 2, negative 1/2. And at 330, it was square root of 3 over 2, negative 1/2. So now I could do the same thing for the 45-degree angles. Okay, so the 45-degree reference angle, okay, I don't want you to draw these arcs I'm about to on your unit circle, but just for the sake of your notes, you can see, so 45 degrees, 45 degrees, 45 degrees, 45 degrees. It's all of the center points at each one. So all of those are going to be square root of 2 over 2. We just need to determine if they're positive or negative. So here, x is negative. So negative square root of 2 over 2, positive square root of 2 over 2. In quadrant 3, they're both negative. So negative square root of 2 over 2, negative square root of 2 over 2. And in quadrant 4, positive and then negative. And then we do the same thing at all the 60-degree reference angles. Okay, every 60 degrees. And maybe it helps, maybe you can see it better if I do it like this. So each of those 4 are going to have 1/2 as the x, and here x is negative, so negative 1/2, positive square root of 3 over 2. And here it would be negative 1/2, negative square root of 3 over 2. And here it would be positive 1/2, negative square root of 3 over 2. The same thing happens for tangent. The tangent values will be the same. So at every 45-degree reference angle, tangent is 1. But what did we say here? Is tangent positive or negative in quadrant 2? So it's going to be negative 1. Is tangent positive or negative in quadrant 3? Tangent? Tangent's the positive one because a negative divided by a negative, so that's positive 1. And in quadrant 4, tangent is negative. So there it's negative 1. Okay, so now we could go around and do tangent at the 30s, square root of 3 over 3. So we said tangent is negative here. Positive here. And then negative again here. And then we could do all the 60s. It's just square root of 3. So here tangent is negative. Here it is positive. And here it is negative again. So now we should have every little blank, every little equal sign, everything filled in on this unit circle. Do y'all have it all? We will be quizzing on quadrant 1 of the unit circle, just quadrant 1, Wednesday. Okay, so you need to make sure you've at least got quadrant, if I give you a blank quadrant 1 of the unit circle, you can fill all of this out from 0 to 90. Okay, now I know when we were doing those tables, I said the square root of 3 over 2, 1/2, and it flips around for 60. That's often mixed up. And so the memory trick I told you was 30 starts with 3. Y'all remember that? You can also use that same trick for knowing that tangent, because the tangents are very similar at 30 and 60. This one has the extra 3. So 30 starts with 3 and has the extra 3. So 30 has the 3 to begin and the extra 3 to end. Okay, so maybe that'll help you remember which tangent has the over 3. It's at the 30-degree reference angles. Any questions so far? Okay, so you got your unit circle all filled in. Now, how do I use that to answer trig questions? So this is the end of it. Here it is, all filled in. Okay, you can look at your blue one if that's easier for you to look at. I don't care. Okay, if I am asked to find the exact value of each expression, I'm going to first find the angle. Where is that angle? And then determine what trig value, what I'm looking for in the ordered pair. So sine at pi thirds. So I'm going to say, okay, so pi thirds is right here. So at pi thirds, sine would be what? What does sine correspond to? The x or the y? It's the y. So at pi thirds, the y value is square root of 3 over 2. So my answer is square root of 3 over 2. So if I can have the unit circle filled out, I can use it to answer all these questions. Okay, so for B, B says, what's cosine at 135? So I'm going to say, okay, so 135 degrees is here. And they want to know at 135, what is cosine? Does cosine correspond to the x or the y? So at 135, the x is negative square root of 2 over 2. Okay, so then C says, okay, what is tangent at 270 degrees? So 270 is straight down. It's a quadrant angle. Now, I don't have tangent written on here, but I did have you just go through and write it on your unit, your blue one. Tangent is y divided by x. Can you divide by 0? So it is undefined. Okay, now D says, what is cosecant at 11 pi sixths? So 11 pi sixths is right here in quadrant 4, 11 pi sixths. Cosecant is the reciprocal of what? Remember, the letters don't go together. It's not S and S or C and C. So the CSC, cosecant, goes with sine. So if sine at 11 pi sixths, that corresponds to the y, right? That's negative half. So what would the reciprocal be? What's the reciprocal of negative 1 over 2? What 2? Negative 2. Okay, box in these answers. Now starting to see how we're using the unit circle. Okay, how about the color? Okay, cosine at 11 pi fourths. If I want cosine at 11 pi fourths. 11 pi fourths is not here on the unit circle, is it? So that means I have to spiral around to get to it. So think about a full circle in fourths would be 8, right? Okay, so 8, I'm at 8 pi fourths if I go around a full circle. And I'm going to keep going. So I'm at 8, 9, 10, 11. So it's right there. At 3 pi fourths, that's coterminal. I'll draw this spiral if that helps. So it spiraled around and came back to it. That's 11 pi fourths. So at that point, at that ordered pair, cosine is what? Cosine is the x, right? So what is it? Negative square root of 2 over 2. Same thing we got in part B, because it's the same. 135 and 11 pi fourths are coterminal angles. Y'all see that? Okay. All right, last one. Let me get a different color. Let's do orange, I guess. I don't know why I got a triangle, not the highlighter. It's not what I wanted. All right, tangent at 19 pi 6. So that's going to require some spiraling, right? Okay, so let's think of this. A full circle in 6 would be 12. You agree? So I'm at 12, 13, 14, 15, 16, 17, 18, 19. Because remember, 6 is every 30 degrees. So if I were to spiral that one around, it went around there. Okay, so at that angle, at this point right here, we want to know tangent. Well, again, I don't have tangent written on this page of the notes, but I had you add it to your blue one. Tangent is y divided by x, and what did that come out to for the 30-degree reference angles? And I'm in quadrant 3, so is it positive or negative for tangent? Positive. Tangent is positive in quadrant 3. It's the only one positive in quadrant 3. Because that's a 30-degree reference angle there. Okay, so if knowing the unit circle is very important, because then you get to use it to answer all sorts of questions about trig of different angles. Y'all feel okay about that? Okay, so we're going to practice this tomorrow. Feel free to use any of those links to resources that are posted in It's Learning to practice or to help learn the unit circle. We will quiz Wednesday over just quadrant 1, and then at the end of the week over the whole thing. Okay, so just quadrant 1 you need to have down by Wednesday. No new homework, but you do need to finish the Delta math from last week that was over radian and degree conversions and coterminal angles.